Hello everyone and welcome. Today we're going to discuss parallel lines and transversals. Just like MC Hammer is showing us, parallel lines are going to be two lines that will never touch each other. They will not intersect. We're going to be exploring some angle pair names, we will be solving for angle measures, and we will be proving lines are parallel using angle measures. Starting out, let's look at some of our angle pair names. The first one is going to be alternate interior angles. So first I'm going to explore that term, interior. So we have our two lines crossed by a transversal. So what is between those two lines is going to be considered our interior. So if we alternate on the interior, it means that we choose one angle that's inside. I'll name him X. And he's going to alternate. So right now, I can see he's to the left of the transversal. Okay. So if I alternate, I'm going to go to the other intersection and be on the right of the transversal. Similarly, if I have an angle Y right here, if I have an angle Y, that's to the right of my transversal, he's going to alternate to the left of my transversal. We're going to stay on the interior though. As you can see in the GIF over here, when the two lines are parallel, right, so this line is parallel to this one, when the two lines are parallel, my angles are always going to be congruent. Pretty neat. Corresponding means they're going to be on the same side, facing the same direction. So again, I'm going to follow my transversal, and I'm going to choose one angle. We'll name him X again. So I can see that he's at this intersection. So then the corresponding angle in the other intersection would also be in the top left corner. Right? So X to X, Y to Y. And similarly, you can see that I would also have corresponding angles in the bottom right corner and in the bottom left corners, right? Always alternating between our intersections. In the GIF, you can see that when the two lines are parallel, these corresponding angles are always the same number. Kind of mesmerizing, right? Lastly, I'd like to mention linear pairs. So as the name linear would suggest, this is going to be when two angles form a straight line together. So for example, I just want to highlight, we have this one point of intersection. So we have an angle X on the left that together with the angle Y on the right form this blue straight line. As such, I know that any straight line is going to add up to 180 degrees, which means that my X on my left plus my Y on the right are always going to sum to be 180 degrees. All right, let's put this all into context. So we are taking a big test. You want to make sure that you know how to approach a problem. The fastest way to set these up is to take a pencil or a highlighter and to say the big angle equals the big angle. So choosing an angle, we're going to label its vertical partner. Then I'm going to stamp it to the other intersection. So I can see right now I have this parallel line and this transversal. So following the transversal to the other parallel line, I'm going to be able to stamp my top left and bottom right. What this tells me is that the measure of angle 1 is equal to the measure of angle 4, is equal to the measure of angle 5, is equal to the measure of angle 8. All the angles that I just highlighted will be equal to each other when these lines are parallel. Okay. Similarly, all the things that I did not color in will also be equal. So the small angles will all be equal to the small angles. So for example, angle 2 would be equal to the measure of angle 7, would be equal to the measure of angle 3, would be equal to the measure of angle 6. right? And when they don't match up with each other, so for example, when I take a big angle plus a small angle, the two together are going to add to equal 180. So for example, if I take the measure of angle 5 plus the measure of angle 6, together those two will add to 180. You can also say the measure of angle 5 plus the measure of angle 2 would add together to equal 180 degrees. Let's do 2 example problems to illustrate the process. So I need to find the measure of angle GHC. Okay, so angle GHC, because the letter H is in the middle, I know that the angle itself is going to be between G to H to C, right here. Okay, so I'm going to highlight the vertical angles. Then I'm going to follow the transversal. And at the other parallel line intersection, I'm going to do the same highlighting. So I highlighted the top left, so I'll highlight the top left and the bottom right. Do you see how 16x minus 3 is highlighted in pink? And 7x minus 1 is not? So, because the angles are marked differently, ... I know that they will add to equal 180 degrees. So 16x minus 3 plus 7x minus 1 will equal 180 degrees. Let's take a moment and see how Desmos can solve any algebra problem for me. So take a second on your paper, copy this down. 16x minus 3 plus 7x minus 1 equals 180 degrees. Because now I'm going to pull up Desmos. I'm going to make sure you're able to see it. Oop. So exactly how it looks, I'm going to type 16x minus 3 plus 7x minus 1 equals 180. So then looking at my graph, where I hit the x-axis is going to be my x value. So when 16x minus 3 plus 7x minus 1 equals 180, the x value is 8. But I have to be careful, because what do they actually want me to solve for? Why, it's the measure of angle GHC, of course. So the measure of angle GHC is 16x minus 3 is 16 times 8 minus 3. And I know that 16 times 8 minus 3, 16 times 8 minus 3 is 125. Not so bad, right? For the next problem, I want to know, is LC parallel to HN, and is MA parallel to JR? So first, let's check LC parallel to HN. So LC and HN. In order for this to be true, we have to find that my stamped angles, so this angle and this one, following the transversal, this one and this one, must always be equal. Remember that you could fill it out. So does 103 match 103? Yes. So I can see that LC is parallel to HN. Sometimes it's just that easy. Now I need to check, is MA parallel to JR? All right, so I see that MA and JR can be stamped the same way. So I stamped the top left, right? So just emphasizing again, you don't have to erase it. I just wanted to show you what I'm doing. So I stamped 103 and the vertical angle. So then I followed along the transversal and stamped the top left and the bottom right. Everything that is pink has to be congruent. If it's not, then they're not parallel. So I'm going to solve for this angle that I don't know. Because it is pink and 77 degrees is not, I'm going to say that x plus 77 degrees must be 180 degrees. So going to Desmos, I said that x plus 77 must be equal to 180. Sorry, let's make this slightly smaller. Perfect. Okay, so I'm going to type x plus 77 equals 180. And then I'm going to zoom out. Sorry, one moment. And then I'm going to zoom out. Aha! I see that my x value is 103 degrees. 103 degrees. Useful, right? So does this pink angle match that pink angle? Yes. The correct angles are congruent. Yay! That's how I know that MA is parallel to JR. You've got this. Take your time and ask plenty of questions.